Hi, in this video we will review basics of angles and measurement of angle in radian and degree, and also at the end we will learn two formulas: length of arc and area of a sector of a circle. Well, let's just start with very basic thing that an angle on a plane, an angle is formed by two rays sharing a common endpoint. Well, rays are half straight lines. They start from a point and then go on. And while an angle is formed when two of these rays meet at their end points. We call that end point the vertex of the angle, and rays we call the sides of the angle. Well, we can have angles of different size, for example this, or then this can go up there. It can be a little bit bigger, something like that. Even this one, so let me just draw this. An interesting one is that the two rays actually just are on the same line. So basically what we call this thing a complete revolution. So start from a line and then turn back to the same ray. Well, measurement of the angle is something that there are two important ways to measure angles. One is in degree, and the other one is called in radian. Well, how a degree is defined is this. So you have a complete revolution, in other words, full circle. Then start dividing it into 360 equal pieces, 360 equal central pieces. If you do that, each piece is an angle, and that angle is 1 degree. That's how we denote it, 1 degree. Well, there is something very conventional on this degree. Why we're dividing circle into 360? Why not 400? Why not 1000? Why not 100? This is coming from a historical background, and it has almost no natural meaning in it. On the other hand, the radian, this is something that has more natural meaning in that. So first, what you do is that you set your angle to be a central angle of a unit circle. What does central mean? Central means that the vertex of the angle is on the center of the circle, and unit circle means that its radius is 1. When you set angle in that way, the length of the arc subtended by this angle is the measurement in radian. While, for example, full circle or complete revolution in degree will give us 360. We just said we divided the full circle in 360 pieces. But for the radian, so it will be the arc length of the full circle. Yes, it means that circumference of the circle of radius 1, which is 2 pi, and then we denote it by a radian. So this is complete revolution. And you will see that in calculus, most of the time, well, I should say always, we will use radian instead of degree. Well, means what? Means that we have to find a way to convert these two measurements to each other, and the conversion formula comes from a very nice fact that, well, it doesn't matter in what measurement you measure an angle. What matters is that the portion of the circle you're taking should be the same, meaning that if you put an angle central, then see it, what is the measurement of the angle? So measurement of the angle over the measurement of the full circle. The circle, or complete revolution in the same measurement. This is always a constant thing. Meaning that if you measure an angle in degree and you measure an angle in radian, these are going to be different numbers, but the ratio of the degree to the 360, the measurement of the complete revolution in degree, is same thing as the measurement of an angle in radian to the full measurement of the circle, which is 2 pi in radians. So these two things are going to be equal. Well, this gives us the conversion formula, and you have to be able to use this thing. Sometimes you will see people using some versions of this. For example, your book writes that, well, 1 radian is 2 pi over 360 degree. Well, that's how it is written. Let's do an example using this formula. So example, convert the measurement. If it is in angle, you turn it to, if it is in radian, turn it into degree, and vice versa. So the first one is, what is 120 degree in radian, and the second one is, what is 5 pi over 4 in degree. Well, this is 100. Let's do the first one. 120. So if we measure it 120 degree to the full circle in degree, must give us the same for if it is measured in radian over the full circle. Well, I can multiply this to the other side. I actually cancel these to get 1 over 3. So radian is 1 over 3 times 2 pi, and then that's same thing as 2 pi over 3 radian. So 120 degree is same thing as 2 pi over 3 radian. And for this other one, we can use the same formula. The 5 pi over 4. What portion of 2 pi is your angle in radian? Then the degree will be exactly same portion out of 360. So this, you see that pi cancels with that, and then degree is 5/8 times 360 degree, which gives us what? Well, we can cancel this. Well, at least divide by 2 is 90. This is 2. Another time, this is 45. So we have 5 times 45 degree, which is what? Which is 225 degree. So you have to be able to use this formula, turn one to another one. Okay, so this ratio here, let me call it the portion of this the circle in that measurement. What portion of that measurement the full circle that angle has. Okay, so this has very important meaning, and in particular it gives us a good formula for length of arc and area of a sector. Well, what does it mean? It means that, okay, if I have a circle, not necessarily unit, any angle r, any radius r, then you put an angle theta there as a central one. Then you may ask, what is the length of this arc subtended by that angle? So the angle cuts this arc, and let's call the length of that by a. Also, you can ask, okay, if I place my angle as a central angle on the circle with radius r, then there will be this piece of circle, we call it a sector. What is the area of that? So this is length of arc this is area of a sector. And here again we have the same idea, the portion, what portion you have taken in the angle measurement will give you the same portion from the whole arc, and it will give you the same portion of area with respect to the full area. In other words, theta in 2 pi, this is the portion, this is in radian, portion of the angle with respect to the full circle. This is going to be same as the ratio of what portion of the area this gets out of the whole area of the circle radius r. And the same story goes for the arc length. So if this is the arc length a, what portion of the full arc of circle does that give us? In other words, I can find the better formula here. So a, the arc length, over the full circle length. This is circumference of circle radius r. This is 2 pi r. This ratio needs to be equal theta to 2 pi, and area of that sector over the area of the full circle radius r, which is pi r squared. This is very nice now, because we can take these two, this equality, and write as, well, I can write a to be 2 pi cancels with that 2 pi. So then we get theta times 2 pi r. Let me write it complete and then cancel it there. This cancels with that. This is theta r. And for this two piece, we have a equals to theta over 2 pi times pi r squared. This cancels with that. And what we get are two nice formulas. The length of arc is going to be theta r. Theta is in radian. And the area of the sector is equal to theta r squared over 2. So these are two formulas that we will use in the course at some point. Well, just one remark is that when theta is 2 pi means that we have the full complete revolution, then A gives us 2 pi r, and area will be 2 pi r squared over 2. These two cancel. Pi r squared are the formulas for the area and circumference. So formulas for the circumference and the area of the circle. Well, let's just do one example at least for these ones, and then that would finish the video. Example: find the length of arc subtended by an angle (60 degrees) when the radius of the circle is 4. Well, so we are looking for A when theta is 60 degrees. Well, you have to be careful. Theta needs to be in radian. Theta is in radian. So we have to first turn 60 degrees into radian. What is this? This is 1 over 6. Then r is 1 over 6 times 2 pi, which is pi over 3. So theta, pi over 3, times r, which is just 4. And that gives us 4 pi over 3. The length of that guy here is going to be 4 pi 3 when the radius is 4. Well, we can actually find the area also. Area would be theta over 2 times r squared. So this gives us 16 pi over 6, which we can simplify and write it as 8 pi 3. So that is the area of the sector for the circle of radius 4. So we learned about different measurements, how to convert these two measurements, radian and degree, and also we learned that this ratio, what portion of this total circle we are taking, can be used to find formula for length of arc and area of a sector.